Hello Algebra 1. In your last week here of distance learning, we are going to combine lessons 6, 7, and 8 all into this one video. Now don't freak out. I'm just going to pick out the most important parts of each lesson. So here we go. In lesson 6, we are going to skip ahead to activity 2, and we're going to use a diagram to show that each pair of expressions is equivalent. So this is a little bit of a review. We are really just going to focus on these first two to review. So with this first one, I set up my diagram. Here's my x plus 3 term, and if I take x times x, I have x squared. X times 3 would be 3x, and so I end up with x squared plus 3x. So we've shown that those two things are the same. My second one, I've set up my diagram. Here's my x plus 2 term. Here's my x plus 4 term. And if I multiply everything out and then combine like terms, I would have x squared plus 6x plus 8. So again, we've shown that those two things are equivalent. Using the diagrams is going to be a helpful tool as we go into the rest of this lesson, so that's why we wanted to review. Okay, in lesson 6, activity 3, we're going to rewrite some expressions, and here we have factored form and standard form. So in this table, you're going to be writing both forms of our quadratics. So we start out with the factored form. My distributive property there, I would end up with x squared plus 7x. Going from the standard form to the factored form right here, I would write that as x times x plus 9. Now, one hint that's helpful here is that I see that I have an x in each term, so that's really a common factor. So I can factor that out here, and then if I take that times x plus 9, I would get back to x squared plus 9. Similar thing right here, I would have x times x minus 8 in my factored form. In the next one, if I multiply it out, I would get x squared plus 8x plus 12, and that's using the distributive property that you guys have done before. In the next one, to write my factored form, I'm going to set up my two sets of parentheses. I'm going to put an x in each of them, and I notice that I have a positive term on the end, and my middle term is positive. So both signs have to be the same to get my last term positive. And if I want the middle term positive, they both need to be addition. And now I'm thinking to myself, what numbers would multiply together to add up to 13 and have a product of 12? And so I'm going to try 1 and 12. And if I multiply all of that out using the distributive property, I would end up with that standard form. It's good as you're doing this to have a little trial and error. You'll start to see patterns that will make things easier for you. In the next one, if you multiply it all out, you'd get x squared minus 8x plus 12. Notice that that last term is positive, so these two need to be the same sign. And I have a negative 8x. Notice that negative 6 plus negative 2 would be negative 8. So there's a pattern that you can start using to help you out. On the next one, I would set up my two sets of parentheses. I'm going to put an x in both of them. And I notice that I need my last term to be positive and my middle term to be negative. So I know I need to be subtracting on both of those. And I'm going to subtract 4 and subtract 3. I know that if I multiply negative 4 times negative 3, I'll get positive 12. And if I add negative 4 and negative 3, I get negative 7. Here's the rest of them factored out. Again, use some trial and error. Keep doing your distributive property. Use diagrams if you need. But our pattern that we start seeing down here is that if I take x plus m times x plus n, this is really what ends up happening. Your middle term is the sum of your m and your n, and your last term is the product. Okay, now we've skipped ahead to lesson 7, activity 2, negative constant terms. Number 1 is a review of what we were just working on, so try completing this table and start again when you're ready. Here's what your table should end up looking like. If your two factors here are switched around, for example, if you have x plus 3 times x plus 10, remember that's perfectly fine. If you have questions on this or if you get stuck, definitely ask me questions, but also consider drawing a diagram to help you, or do your distributive property over and over and over again. Draw those arrows, Use that to help you. Again, some trial and error here is okay. Okay, in this table, you'll start to notice that each of the constant terms on the end is negative, and so what we need to focus on is how to get that. Well, you're going to have one positive term and one negative term in your factors. So on our first one here, I would do x and x, and I want factors that multiply to 36 and add to negative 9. So I would do a negative 12 plus 3, because negative 12 plus 3 is negative 9. And if I multiply them, I get negative 36. Try the other two and start again when you're ready. All right, here's what we should end up with. And again, while you're working on these, if you get stuck, definitely draw a diagram or multiply everything out using your arrows and the distributive property. It can be really helpful. Trial and error here is good and it's okay, so keep working at it, guys. Okay, now we are on to lesson 8, activity 3. So we've skipped ahead quite a bit. What if there's no linear term? Remember, that's like your middle term with x in your quadratic. So we're starting out with a table again. And if I multiply this first one all the way out, I would get x squared plus 10x minus 100. And if I simplify that, I just get x squared minus 100, because those middle terms end up being 0. And that's okay. You can have a quadratic that just looks like that. What we're working on here is to see a pattern that we can use to make factoring easier when there is no middle term. Okay, multiply out these next two and start again when you're ready. Okay, here's what I would get when I multiply out those next two. With this one right here, it's okay if you wrote it as negative x squared plus 16. That is the same thing, and usually we would put that x squared term first, but it would need to be negative x squared plus 16. Keep that negative with it. All right, going to our next one. Now we are going to write the factored form from the standard form. Maybe you saw a pattern forming here, maybe we didn't, but I can still set up my two sets of parentheses, and I'm thinking what numbers multiply together to get 81, so I'm thinking 9 times 9, and they would add together to get 0, because there is no middle term. Well, I could do a plus 9 and a minus 9. So there's my factored form right there. Try the next two and start again when you're ready. Okay, here's your next two. My first one looks really similar to this one up here. It's okay that the y is second. Again, normally we would put it first, but it's perfectly fine to write it this way too. It actually makes it a little bit easier right now. Your second one down here, notice that this is not just z squared, it's 9z squared. And so I wrote that as 3z and 3z, because if I multiply those together, I get 9z squared. My middle term would disappear here, because I would have a negative 12z plus a positive 12z, that's 0, and then I would get my negative 16 when I multiply it out. Try the next two, start again when you're ready. Okay, in this first one, my 25t squared, I split into 5t and 5t. And again, my middle term would be gone, and I would end up with negative 9 times 9 to get my negative 81. If you're noticing that your two terms are the same except for a positive and a negative sign, that's a good thing. That's the pattern we're looking for here. On the next one, it has fractions here. Don't let the fractions scare you. Just multiply across the top, multiply across the bottom. We would get negative 4/25. Try the rest of these. Try all four and start again when you're ready. Okay, the first one, excuse me, would look like this. That's similar to what we've been working on, just with fractions, but don't let the fractions scare you. The next one, this one would still have a linear term because these are both positives, and so your middle term would not disappear. It would still be there. This one, there is no nice number that multiplied by itself gets you 6, but we could do the square root of 6. And so we could write it as x plus the square root of 6 times x minus the square root of 6. And that's because the square root of 6 times the square root of 6 gets you 6. So that was kind of a weird one. This last one is impossible. They told us that one of them was impossible. This is the one that does not work. And that's because there's no way that I could fill in my parentheses here to get a positive 100 on the end and no middle term. So this one would be called impossible or unfactorable.